In this fourth and last tape of the centrifugal pump maintenance module, what I'm going to be doing is to discuss the remaining assembly steps on the pump that we've been following in order to complete the assembly of that pump, test operate it, and get it service again. So I suppose before we begin the next step in our assembly process, we ought to review the status of our pump at this time. We said at the end of the last tape that the rotating element had been installed in the pump, the bearings had been assembled, and that the next major step in the operation was to install the top half of the pump casing. So our workman is down there prepared to install that casing half. So let's go down and see how he's doing. On this particular pump, before installing the top half of the pump casing, it is necessary to first install the studs for the gland followers for the packing seals on each end of the pump. This is a pretty common method of construction for centrifugal pumps. The studs, which are used for the gland followers, have an opening, or clevis almost, on one end of the stud. This is slipped over one of the studs which is used to hold the two casing halves together. For this reason, they must be installed before the top half of the casing goes on the pump. It can be very embarrassing to go through all the rigmarole involved in installing that top half of the pump casing, only to discover you have to lift it again in order to set these studs in place. So what the workman does is to take the studs from the protective plastic bag they've been stored in, set them in position, and then start the nuts on the end of them, simply so the nuts won't be lost. The workman then repeats the same steps for the seal on the outboard end of the pump. He removes the studs for the gland follower from the plastic bag in which they've been stored, and he then removes the nuts from each stud to allow installing them. And they are installed in the same manner as we've just seen. The packing gland studs are placed over the two studs in the pump casing which holds them in position. The gland follower is then slid up over them, and the nuts are threaded on as before. Now, as we're going to discuss later on in this tape, the nuts and the gland follower will again be removed and drawn back to allow packing the pump. But the nuts are placed on the studs at this time to prevent their being lost. Now, with these steps completed, the two workmen are then prepared to begin work in order to install the top half of the pump casing, which, as you'll recall, has been blocked up in an upside-down position to allow casing inspection. So they make use of lifting equipment and blocks in order to lift that casing half and install it back on the pump. And as we're going to see, the steps involved here are essentially the reverse of the steps that we saw earlier for removing the top half of the casing. Now, as you'll recall, they use a total of 3 lifting devices, 2 chain falls and a come-along, and of course a number of wooden blocks for protection. The first step in the operation, and the one we see being performed here, is to turn the casing over, that is, to turn it back into its normal position. So the two workmen set wooden blocks against the pump to prevent damage, and then lift the casing with the 2 chain falls attached to a shackle which is installed in one of the casing flange holes. This allows lifting the casing up on edge so that it can be turned over and then set down again on its parting flange. So the casing is lifted, swung over, and set down, as before on protective blocks. Now, the reason it's set down, of course, is to allow for reconnecting of the lifting apparatus. What this means in this case is disconnecting the 2 chain falls from the shackle on the parting flange and connecting them together with the come-along to the eye on the top of the pump casing. Then, by coordinating the operation of all 3 lifting devices, the 2 chain falls and the come-along, the top half of the casing can be lifted, swung over the pump, and lowered into its proper position. Now, as I said before, when we discussed the removal of this casing half, the exact procedures that you see being used here may not apply in your particular plant. The important thing to remember is that in all cases you use only approved lifting equipment, which is rated for a capacity in excess of the weight of the pump casing that you're lifting, and of course that you follow approved rigging procedures. But the procedures must be adjusted to the particular situation. While this job required 3 lifting devices, A pump that you're working on may require only one or two, but it's important that the procedures and equipment used fit the equipment you're working on and the environment in which that equipment is installed. With the casing safely suspended from the eye on top, the workman then removes the shackle from the flange hole. Now, this is the shackle he used in order to attach lifting apparatus to turn the casing over. Now, he has one more important step before the top casing half can be lowered onto the lower half, and that's to set the gaskets in place on the parting flange. Now, these gaskets, of course, were cut earlier so that they would be ready when this step came. However, he did not put them in place on the flange until this point. Now, the reason for this is that some of the earlier operations could have caused damage to the gaskets or knocked them out of position. So instead, it's good practice to keep the gaskets in a safe location until right before putting the two casing halves together. But don't forget to put the gaskets in place. Again, this can be very embarrassing if you get this casing lowered into position and only discover you have to lift it again in order to put the gaskets in. So with the two-piece gasket set in place on the parting flange of the lower casing half, the workman is then ready to lower the casing into position. Now, this is done as before by coordinating the operation of the lifting devices. So his helper carefully and slowly slacks off on the come-along, while the workman tightens the two chain falls which are suspended directly over the pump. This coordinated operation then results in the top casing half being swung over the lower casing half. Then begins the most critical part of the operation, and that's lowering the top casing half down over the rotating element. This must be done carefully and slowly, as you see here, with careful observation through the gap between the two parting flanges to be certain that the casing half is fitting properly over the rotating element, is not binding or interfering, because as you can imagine, if it did interfere with the rotating element, then severe damage to the impellers, wearing rings, and so forth could result. Instead, the casing half should be lowered straight onto the pump, and there should not be any interference or binding. Now, if there is interference, if the casing hangs up, do not use force to seat it. Instead, you should lift it back up and determine why it is interfering and correct it before again lowering it into position. Now, in this case, as you can see, the top casing half seated readily onto the lower casing half. So the two workmen lowered it into position, and after assuring that it was seated properly, disconnected the lifting apparatus that they had been using. Now, another important point is the alignment between the two casing halves. Now, this can be accomplished in a number of ways. As I told you earlier in this program, a number of pumps make use of guide studs for removing and installing the top casing half. Now, this particular pump does not, but it is provided with two dowel pins which are used to maintain alignment of the two casing halves. Now, one pin goes into holes on the flange on one side of the casing, while the other pin goes into a similar set of holes on the flange on the opposite side of the casing. So the workman takes the two dowel pins, inserts them in the appropriate holes, and then drives them into position with a ball-peen hammer. Now, this is done, of course, before the casings are bolted together, because the purpose of the two dowel pins is to maintain proper alignment between the two casing halves. So after inserting the two dowel pins, the workman then begins installing the nuts on the studs which are used to hold the two casing halves together, and he will also install a number of nuts and bolts in the various holes around the parting flange. So while he finishes up putting these nuts and bolts into their proper locations, why don't we take a break and give you a chance to review what we've been discussing with your instructor. Well, at the end of our last segment, our workman had completed installing the top half of the pump casing, and as we left, he was threading on the nuts on the studs which attach the two halves together. And we said he was also going to install the nuts and bolts that are used to attach the two halves together. So the next major step in the operation then is to tighten those studs and bolts in order to attach the two casing halves together. But it's extremely important that these be tightened properly, That means tightened to a specified torque value and tightened in the proper sequence. And this sequence is extremely important because if it's not done properly, you can distort the top half of the casing, which will result in a leak through the casing flange. In addition, if you distort it badly, loosening and retightening may not correct it. The casing may take a permanent set, and then you've really got a problem to deal with. So again, let's catch up with our workman and see how he performs his tightening operation. Once again, the manufacturer's instruction book should be consulted before you begin this tightening operation, because the manufacturer's book will give you the specified torque value that the bolts and studs should be tightened to. And it may also give a specific tightening sequence. If no sequence is specified by the manufacturer, then the studs and bolts should be tightened in a crisscross pattern, starting in the center of the casing and working towards the ends. Now, in the case of our particular pump, a pattern was specified by the manufacturer, and as it turned out, it was almost a reverse of what I just described. That is, the sequence the manufacturer specified instructed the workman to start at the outward ends of the casing and work towards the center, but again in a crisscross pattern. But the important point to remember is that the bolts must be tightened in the proper sequence and tightened to the specified torque value. And on some high-pressure pumps, this may require tightening in 2 or 3 steps, that is, 2 or 3 different torque values in a progressively increasing manner. But in any event, read the manufacturer's manual and tighten the nuts and studs as specified by the manufacturer. Because as I told you before, if this step is not accomplished properly, the casing may be distorted, and this may well result in a leak between the parting flanges. Now, at the end of the operation that we've just seen, that is, after all the studs and bolts which are used to attach the 2 casing halves together have been tightened in the proper sequence and to the proper torque value, there's a very important check which should be performed before proceeding with any further assembly steps. And that's what you might call a modified test operation of the pump. What I'm talking about here is turning the rotor by hand. Now, by hand is a misconception because frequently, as it did in this case, a strap wrench or some similar tool is required in order to turn the rotor. Although with smaller pumps, you may be able to just turn it by hand on the coupling. But what's important is to test operate the rotating element to be sure that it turns freely and does not bind or drag. And even on very large pumps, the rotating element should be able to be turned by hand, provided you lubricated the bearings during assembly. Any binding or dragging indicates that there may be a problem in the assembly of the pump, and it would be wise to again open the casing and check it out. So if we assume then that this test operation proved successful, that is, there was no binding or rubbing or unusual sounds or anything like that when the rotor was turned by hand, then we're ready to continue with our assembly process. Now, the next step in assembling our pump is to reinstall any heat exchangers or other accessories which were removed during the course of disassembly. And if you recall, on our pump there was a heat exchanger, and that was a water jacket on the thrust bearing on the outboard end of the pump. Now, if you remember, when this water jacket was removed, there was a gasket used for the water jacket. Well, our workman cut a new gasket using the old one as a pattern, and it's been stored in a plastic bag for protection until now. So the new gasket is set in the proper position before installation of the water jacket itself. With the gasket in place, the water jacket is then lifted and set into the proper position on the pump, which means it is slid up over the thrust bearing and over the studs which hold it in position. Then, with the water jacket in place, the nuts which attach the water jacket can be threaded onto the ends of the studs. As with the other small parts that we have seen throughout the reassembly process, after cleaning, the nuts were identified with a tag and stored in a plastic bag. As I said earlier, this type of storage and identification of small parts makes reassembly of a major component, such as a centrifugal pump, much easier. Now, after all of the nuts have been threaded onto their studs, they need to be tightened to a specified torque value, which, as before, is determined from the manufacturer's instruction book. So after checking the specified torque value in the manufacturer's instruction book, the workman then takes a torque wrench and, of course, a socket of the appropriate size and tightens the nuts in a crisscross pattern up to the specified torque value. This then completes the installation of the water jacket on the thrust bearing. Now, as I said before, the number and type of accessories attached to a centrifugal pump will vary from one pump to another. In the case of our pump, the only such accessory was this water jacket. So after its installation, the workman was then ready to begin connecting piping, both to the water jacket and to the top half of the pump casing. So what we see here is connecting the cooling water to the thrust-bearing cooler. In addition to this, the workman will also connect the various other connections which were disconnected in the course of disassembly of the pump. Now, depending on the particular pump involved, this may include such things as vents, drains, instrument connections, seal water connections, and so forth. So while our workman continues the assembly of these various piping components, I think this might be a good time for us again to stop the tape, take a short break, and review what we've been discussing. Well, while we took our break, the workman that's been overhauling this particular pump completed the installation of the various piping connections which were necessary on our pump, which included, as I said before, such things as seal water connections, vents, drains, instrument connections, cooling water fittings, and so forth. Okay, well, we can assume now that that work has been completed, which means that our pump is almost ready to go back into operation. But there are a few more major steps that I'd like to discuss with you. The next thing our workman does is to connect the pump rotor to the rotor of the motor which drives the pump. Now, of course, before actually making the connection, he carefully aligns the two components and then installs the nuts and bolts which are used to attach the two halves of the coupling together. Now, there's another major step involved, too, and that's one that we've mentioned several times already, and that's the installation of the packing and lantern rings for the two seals on our pump. So let's join our workman back out in the plant and see how he accomplishes this packing step. Before the packing could be installed in the pump, the workman had to first cut it to lengths of the proper size. So after determining the size and type of packing required from the manufacturer's instruction book, the workman and his helper obtained packing of the appropriate type and size and made arrangements to cut it into rings of the proper length. Now, in this example, the way this was done is to obtain a piece of pipe having the same outside diameter as the packing sleeves on the pump. This way, the packing could be wrapped around this piece of pipe to determine the proper length and then cut off as necessary. Now, this is a very important step. The cutting has to be done in such a way that when the packing is wrapped around the packing sleeve, the ends of the packing join together perfectly. That is, that they match flatly, and there's not a V-shaped notch where the packing ends join. This is why it's important to either cut the packing while it is wrapped around the shaft, or in this case a piece of pipe of the proper diameter, or to carefully mark it while it is wrapped around the shaft or a piece of pipe, and then cut it at that angle. Because if it's cut while it's laying flat on the table, you will then find after wrapping it around a cylindrical object, such as a pump shaft, that it has a V-shaped gap. So in this case, the workman cuts the packing one ring at a time. That is, he makes one wrap around the piece of pipe, and then while holding the packing in that position, he cuts it off at an angle to match the end of the previously cut packing. These operations are simply continued until the required number of rings of packing have been cut. For purposes of our pump, that required number is a total of 12 rings. After the workman has completed cutting all 12 rings, he is then ready to take the packing down to the pump and install it. Now, as you probably recall, the last time we saw the seals on our particular pump, the gland followers had been set in position, and the two nuts which hold them in place had been threaded onto the studs for the gland followers. Now, the reason for this, of course, was simply to keep these components in position and to be sure that they didn't get lost. So the first step in packing installation is for the workman to remove the nuts which hold the followers in place, and then pull the followers as far back or as far out of the stuffing box, if you will, as possible to allow packing installation. Now, of course, he works on one seal at a time, and what we're watching here is the work involved in the inboard or coupling end seal. With the gland follower pulled back as far as it will go, the workman then installs the first ring of packing, which he had previously cut. He wraps the ring around the shaft, verifies that the two ends butt carefully and well together, and then pushes this ring of packing into the stuffing box. Now you notice that the joint where the two ends join is at the top of the stuffing box. He then pushes the ring in as far as he can using the gland follower. Now it's necessary to seat each ring of packing in the stuffing box as it's installed. In some cases, this can be done by the use of a split bushing. However, in this particular pump, there was not enough space to allow the use of a bushing. So instead, what the workman does is to take a packing tool, is a packing removal tool, which has had the screw end of it cut off. This gives a blunt object which can be used to press the packing ring into the stuffing box as far as it will go. Now, the ring is then followed, of course, by the next ring. And this is installed as before. It's placed around the shaft, and he verifies that the two ends properly join together. Now you'll notice that he installs this with the joint staggered 90 degrees from the joint on the first ring. Now there's a specific rule which should always be followed for staggering joints of packing, and it's based on the number of rings of packing to be installed. You'll find the rule spelled out in the student workbook for this segment of the program. But let me just tell you that in this case there's 4 rings of packing to be installed before the lantern ring, and this meant that the joints should each be staggered 90 degrees from one another. Now again, after installing the second ring of packing, the workman verifies that it is seated as far as it will go into the stuffing box by first pressing it in as far as he can with a gland follower, and then seating it with a blunt object, in this case that packing tool which has had the screw cut off. This ring is then followed, of course, by the third ring, and the installation here is exactly the same. The ring is placed around the shaft, and in this case, to maintain the 90-degree staggering of joints, it is installed with a joint at the bottom of the stuffing box. So after properly positioning the ring and verifying that the ends join up as they should, it is pushed into the stuffing box and pushed as far in as possible with the gland follower. And then, as before, he finally seats the ring by using his blunt object. Now this seating of packing rings is very important. Each ring, after being placed in the stuffing box, should be firmly seated as far as it will go into the stuffing box. If you fail to do this, you may find that the rings bind or hang up as the packing is tightened. And this means that some of the rings will not seal as they should, and you place a heavier load on the remaining rings, which means that the packing will wear out prematurely. Now the next step, of course, is to install the fourth ring of packing. And this is installed as before, placing it around the shaft, verifying that the ends meet as they should, and positioning the joint in the proper location, which we said in this case was 90 degrees from the previous joint. After doing this, the ring is pressed into the box by hand, and once it's inside the stuffing box, it is pushed further in using the gland follower. After pressing it in with the gland follower, he then firmly seats the ring to be certain it's as far into the stuffing box as possible. Now, as I said earlier, there's a variety of tools that can be used to firmly seat these rings, but you should be sure not to use a pointed object, because that, of course, can damage the packing. Now, the next thing required to be installed was the lantern ring. This particular pump calls for 4 rings of packing, followed by the lantern ring, which is followed by another 2 rings of packing. Now, how does the workman know this? Well, in 2 ways. He refers to the manufacturer's instruction book before installing the packing. That gives him the information. And he also made notes during the disassembly of the pump. He counted the number of rings that were installed before and after the lantern ring when it was removed from the pump originally. The lantern ring is installed in much the same manner as the packing. It's placed in the stuffing box and then seated using the gland follower. Now you notice that the stuffing box is now getting so full that the end is no longer necessary to use the packing tool in order to seat the rings. They can be pushed in as far as necessary by the use of the gland follower. Now after the lantern ring comes two more rings of packing. So the workman installs the first ring as before, placing it in the box, verifying that the ends butt up, and then inserting it into the stuffing box, and finally seating it using the gland follower. Now this ring was installed with a joint at the top of the stuffing box. Since there is only two rings installed after the gland follower, following the rule that you'll find in your student workbook, the second ring is installed with a joint 180 degrees from the first ring. So the second and last ring of packing is placed in the stuffing box with the joint straight down. This is installed in exactly the same manner as the earlier rings. Set in position, the workman verifies that the joint butt up as they should, and then the ring is followed by the gland follower. Now since this is the last ring to be placed in the stuffing box, he slides the gland follower up over the studs, which are used to hold it in place, and of course used to adjust the packing. And he is then ready to thread the nuts onto the studs, which hold the gland follower in place. Now once both of these nuts are installed, comes an extremely important step. These need to be tightened up sufficiently to seat the packing in the stuffing box, but not so much that the packing is jammed in and compressed unnecessarily. The idea is to get the packing seated in the box, but to leave it loose until the pump is filled with the fluid which it normally pumps and is in operation, because a final adjustment of the pump packing is not done until the pump is actually running. So what you see the workman doing here is what I might call an initial tightening of the packing. And this requires a certain amount of feel and judgment, which you will only get by experience. But the idea is to tighten the packing up snugly, for want of a better term. Simply to tighten up the packing nuts sufficiently to ensure that the packing is seated into the stuffing box, but not compressed any more than is necessary at this point. So once the packing has been snugged up, the workman will then loosen these nuts again. After he has taken them up sufficiently, and taken them up evenly, I might add, to be sure that the gland follower goes in straight, he then loosens the nuts again and backs them off to a finger-tight condition. They will be left in this finger-tight situation until the pump is ready to be test-operated. After completing these steps on the inboard packing seal, the steps are then repeated, of course, on the outboard seal. He installs the packing, one ring at a time. He installs the lantern ring at the proper point in the sequence, and, after all the packing is installed, completes an initial tightening of the nuts for the gland follower, and finally he leaves them finger tight. Well, with these steps completed then, our pump is pretty near ready to run. We've got it reassembled, all the components have been assembled, piping connections hooked up, the coupling has been made up, we have now completed the packing installation. As I said, the pump is almost ready to run. But I think before we get into test operation, I would again like you to stop the tape at this point and review the material we've been discussing with your instructor. Well, we said at the end of the last segment that our pump was almost ready for a test operation. But there are a few more preliminary steps which have to be accomplished before we can start this pump. Can you think what they might be? Well, most of them are pretty logical. For one thing, we still have to put oil in the bearings. And this can be one of the most embarrassing things in the world, to start a pump after an overhaul and find that you've forgotten to put oil in the bearings and end up, of course, destroying a bearing. In many cases, the coupling, too, requires oil, and ours does. It's an oil-filled coupling design. So again, oil must be added before the pump is started. And of course, you have to comply with your facility's tagging procedures. Be sure that all tags are properly removed and that valves are operated as necessary. This means such things as the inlet and outlet valve being opened, and of course vents, drains, and similar valves being closed. So let's assume then that these preparatory steps have now been completed. We have oil in the bearings and in the coupling. The pump is properly valved in with all protective tags removed. And of course that the breaker for the electric motor which drives the pump has now been racked in and its protective tag removed. And we're ready to start the pump for a test operation. Now of course during this test operation the pump should be thoroughly and carefully checked for any indications of abnormal operation. This includes a monitoring of the temperature of the bearings and the seals. In many cases, as is the case here, this is done simply by feeling them in order to determine if there's excessive temperature. In addition, the pump should be checked for smoothness, because obviously following an overhaul the pump should be running quite smoothly. Any excessive vibration would be cause for concern. And it's during this test operation that the final tightening of the packing is done. Now this tightening frequently takes an extended period of time, perhaps a few hours, in some cases a few days. It depends really on the type and size of the pump, the type of fluid being pumped through the pump, and of course the type of packing being used. The packing is tightened progressively. It's never tightened so much that the leak-off is eliminated. As I'm sure you're aware, a certain amount of leak-off is required for cooling and lubrication of the packing. Also, as you see here, the workman monitors any gauges installed on the pump, such as suction and discharge pressure. Again, just to be certain that the pump is operating properly. And he continues to monitor the leak-off from the packing seals, making adjustments as necessary until a point of stabilization, if you will, has been reached. And as I said before, this frequently takes many hours or sometimes several days until the packing is seated and the leak-off is reduced to a proper level. So at the conclusion of this test operation, then, we have covered all of the major steps involved in overhauling a typical centrifugal pump. If you recall, clear back to tape 1, we began with a pump which was fully assembled but in need of repair. We saw all the major steps involved in disassembling that pump. And once it was disassembled, we saw some inspection procedures to determine which parts needed repair or replacement. And included in these procedures were a number of precision measurements. After the parts in need of repair or replacement had been identified, we took care of the repairs and the replacement steps, and we began reassembling the pump. We followed all the procedures involved in putting this pump back together again. And finally, we conducted a test operation of the pump for a final packing adjustment and checkout. Now, as I told you at the beginning of this program, I'm sure that the pumps you'll be working on will not be exactly like the one that we've been overhauling. But what you will find is that the steps and procedures that we've been discussing apply equally as well to your pumps as they did to the one that we've seen. And I'm also sure that you will find that the information you've learned in this program will help you in repairing those pumps efficiently and safely. Now, should you have any particular questions about the pumps in your facility, be sure you discuss them either with your instructor at the conclusion of this program or with your supervisor when you get out on the job.